Hello everyone. So in this particular video, we are going to discuss question number 62 of GATE DA25 exam, and this question is based on DBMS subject SQL part, right? SQL part. Okay. So here we have two table, loan and borrower, and the query is given to us. So this is basically a relational algebra query. Okay. So I hope everyone knows what is relation algebra, what is tuple relation calculus, and what is domain relation calculus. Okay. So you should know all these three relational calculus thing. Okay. So here we can see we have a pi. So projection, branch underscore name, customer underscore name, in bracket loan, and this symbol is there. This symbol indicates what? Natural join between loan and borrower. And then we have a division operator here, projected branch underscore name from the loan table. Okay. So I hope everyone knows about the division operator, right? So division operator means what? For all the values of this particular field, there must exist some value corresponding to the customer name here, because we are dealing with the two table here, right? So we'll discuss with the help of example in this particular case how this division operation works. Okay. So first you should know that how projection is there. So project branch underscore name from loan. So if you project the branch underscore name from loan, that is basically this particular column, right? But if you remember, projection will always give us what? Distinct values. Distinct values. So if you see here, we have Banjara Hills, then we have Kondapur, right? Then we have SR Nagar, and then we have Bala Nagar, right? So that's it. These are the distinct branch name we have. We are not going to consider the duplicates here. So this is equivalent to what? Select distinct branch underscore name from loan. So this is basically equivalent SQL query for this particular relational algebra expression. Okay. Select distinct branch underscore name from loan. Okay. Now we have this 4 branch name from the loan, right? 4 distinct branch name we have. So what about this particular thing? Loan, natural join borrower. Now if you see here, we need to project what? Branch name and customer name from the join of loan and borrower. So how natural join works? Based on the common attribute. So based on common attribute, automatically these two tables will get joined. Now if you see here, which one is common? Loan number you can see here, right? Now you can see this one. L1 is going to join with this L1, right? So we will get this L1, Banjara Hills 90,000, Anand, right? Again L1, Banjara Hills 90,000, Karthik. So these two new rows we will get after joining operation. Okay. And what we need to project? Branch name and customer name. So if we look at this natural join loan and borrower, what we are going to get? First one is L11, Banjara Hills 90,000 here, and then Anand. Okay. Again L11, Banjara Hills 90,000, Karthik is there, right? Now L14 will get match with L14 here. So we just have one L14. So L14, Kondapur 50,000, again Karthik here, right? Then we have L15, L15 is only here. So L15, SR Nagar 40,000, and then we have Ankita here, right? Now L22, we have L22, we have L23, 2 times it will get joined 2 times, and then we have L25 here, and we have L19 here as well. Okay. So you can do this particular joining here, but we just need to project branch name and customer name. Now here again projection operation is there. So this is going to give us the distinct values of branch name and customer name. So in this case we just have a one attribute, but here it is going to consider the combination of both the attributes. So that must be distinct. Okay. So let me complete this one, then you can easily understand this particular problem. Now next is L22. So L22 we have SR Nagar, then we have 25. Again we have L22. Yes, Karthik is there, right? Again we have L23, Balanagar 80. L23 is here. Again Karthik is there, right? Then we have again L23. You can see it will get matched with this record also. L23 again Balanagar again 80. But here we have a Sunil, right? And then we have L25. L25 we have Kondapur. We have 70,000. And then we have again Sunil. And then we have L19. L19 will try to match with this one. L19 SR Nagar 60,000. And then we have a Gopal. Now if you see, this is basically what? This is a branch name and this is a customer name. Now we have to take the distinct combination of branch name and customer name here, right? So here you can see Banjara Hills Anand is one of the combination. Banjara Hills Anand is one of the combination. We have Banjara Hills Karthik is one of the combination here. Yes, we have Kondanagar Karthik is there. Kondapur Karthik is there. Then we have SR Nagar Ankita. Yes, we have one more unique distinct value we can say. Then we have SR Nagar Karthik. Yes, combination is different here, right? So we have to take the combination of these two attributes. Again, SR Nagar Karthik is there, right? Then you can see Balanagar Karthik again unique. Balanagar Sunil again unique. Again, this one you can see Kondapur Sunil. Kondapur Sunil we have no. Again, this will be unique. And then we have SR Nagar Gopal. Again, so all the combinations of this branch name and customer name is unique here. Okay. Now, so in the output of this particular thing, these two columns will be there. This branch name and here we have a customer name. So both the columns will be there like that, all the entries, because we don't have any duplicates value here. Now this is basically a divide by this particular output here, right? Now we need to find out for what value of customer name this all the four values of branch name satisfied. Okay, so there must exist a customer name for all these four branches. That is what a division operation is. When we talk about division operation, always remember for all. Okay, for all the values of branch name here, you can see we have one customer name here. So we need to find out a customer name such that it belongs to all the branch name here. And what is that customer? Let's try to find out. What about Anand first? Anand belong to BH. Yes. Kondapur is there. No. So Anand is not correct. What about Karthik? Karthik have BH. Yes. Karthik have Kondapur. Yes. Branch name. Karthik SR Nagar. Yes. Karthik SR Nagar as well. Karthik Balanagar. Yes. Karthik Balanagar as well. So we will get the output as this. Customer name is what? Karthik here, right? So one entry as of now. What about Ankita? No, just one entry. What about Sunil? We have for Balanagar and Kondapur, but for Sunil, BH and SRN entry is not there. So Sunil also will be not in the output. Same for Gopal. So we just have one entry in the output, that is basically a Karthik. So number of tuples written by the above relational algebra expression is what? 1 here. So 1 is the correct answer here. Okay. So if you practice this enough, you will not take this much time. Okay. You can easily solve this within a second. And for this joining operation, you require some practice. Okay. Other than it's just a conceptual part. Okay. But you should know this division operation and this projection here, how it works. Okay. I hope you understand the video solution for this particular question. Please try to solve similar type of question for this particular question. Okay. Because in the next year, they can change the table, they can change the expression, or instead of relational algebra, they can ask SQL or TRC or DRC. Anything is possible. Okay. So try to solve a previous year question in that particular manner. So we have already added a question based on this and the possibility of those questions as a part of our test series. Please try to attempt those particular questions. Okay. So that's it from my side. Thank you.